Hello, today we're going to talk about exponential and the properties. 6.1. Okay, so let be a positive real number and n be any real number. Then a to the n, where a is called the base and n is called exponent. So that means, oops, that means what? Oh, I should do common, sorry. That means you have multiple a multiply together totally n eighth. So for example, if n means n equal to 3, that means a to the q is equal to a times 8, 3 a's multiple together. So when the direction as they simplify, this means all the exponents are positive. Each base only occurs once and there are no parentheses. There are no power returned to powers. I will explain it later as the course goes on. Okay, so product rule. Evaluate by expanding first 5 to the third and 5 to the fourth power. Leave your answer with base 5 looking at your final answer. What is the relationship between the exponent and the exponent from the original expression? So now let's take a look. 5 to the third, we can write it as what? 3, 5 multiple together. 5 to the fourth, you can take it as 4, 5 multiplied together. So totally, if you combine these two together, they will become what? 7, 5 multiple together. So that means what? 5 to the third times 5 to the fifth is equivalent to 5 to the third at 5 to the fourth. If two exponents they multiply together with the same base, you can write as just the power, the sum of their powers. Okay, so here is the product rule for the exponent. Now a be the positive real number and n and m be the real number. Then a to the n power multiply a to the n power is equal to a to the n plus m. So in order to add the exponent, the base of the factors are required to be the same. So here has to be a and a. So for example, if you have a to the m times b to the n, then you can just add the power. You can just add the exponents. Okay, apply the product rule for the exponent to simplify the following expression. So this is equal to what? 7, since they have the same base. So we have a 2 plus 10, which is 7 to the 12th. In here, while the base is different, but this is multiplication, right? So since this is a multiplication, by the commutative property of a multiplication, you can rearrange that. That means we can let the numbers multiply the numbers and the letters multiply the letters. Don't forget the negative sign is really important. So when the numbers multiply together, this is equal to negative 24, and then the variables with the exponent equals to what? Since they're multiplication, so that means we just need to add all the exponents. So this one, it seems didn't have exponent. That means the exponent is equal to 1. So that's why here is 1. Okay, so this is equal to negative 24x to the 6th power. Okay, so the next one is the same, even though they have two variables. So by the commutative property, we can regroup them, let all the letters, they're going to group together the same variables, so we group them together. Basically, it's similar to merge the like terms. So 5 times 2, a to the 3rd power, and then a to the 9th power. After we're done with these, we still have b to the 7th power and b to the 2nd power. and then c to the 4th power. Now we would group them. After we group them, we have 10, and then a to the 3 plus 9 power, and b to the 7 plus 2 power, and then c to the 4. So we have a to the 12th, b to the 9th, and c to the 4th. Okay, so the next one is evaluate by expanding it first. So we have 4 to the 6th, and then over 4 to the 3rd. So let's expand them. So 4 to the 6th means you have 6 fourths multiplied together, and for the denominator we have 3 fourths multiplied together. So in fraction, if they're the same, they can cross cancel, right? They can cancel each other out. What's left? We will have 3 4 left in the numerator, so which is 4 to the 3rd. So in here, now you might find that. So if it's division, fraction means division, right? So the exponent should be subtract from the numerator, subtract the denominator. Okay, in here, it says the quotient rule for exponents, let a be the positive real number and m be any real number. So a to the n over a to the m equals to a to the n minus m. In order to subtract exponent, the base and the dividend and divisor are required to be the same. Be sure that the denominator exponent is subtracted from the numerator exponent. Okay, so apply the quotient rule for the exponent to simplify the following expression. So here is the same. We have x, 7 minus 4, which is equal to x to the 3rd power. Here, similar to the trick, we just let the variable with the same base. They have to be the same base because the base of the divisor and dividend has to be the same. So that means we want a 7 minus 3 times b 2 minus, remember this one, if they didn't have exponent, it doesn't mean 0, it means 1. So this is equal to a to the 4th times b to the 1. Okay, next one is the same, numbers divided by the numbers, a over 6, right? And then m is 7, subtract 5, n is 4 minus 1. So we still need to simplify here. So they can both divide it by 2. So this is 4, this is 3. So I have 4/3 m to the 2nd power and n to the 3rd power. Okay, power rule of the exponent. So let's expand into the 3rd power and then 2 to the 2nd. So 2 to the 3rd power and to the 2nd. Next, do everything inside the parentheses first. So I have 2 to the 3rd means 3 2's multiplied together. And now take a look. What's that mean? We square them. Square means what? Everything you multiply itself again, right? So that means I want to multiply the parentheses itself. So how many is totaling? 6. Very good. So 2 to the 6. That means what? If it's power rule, that means the exponent, they multiply. So let a be any positive number and m to be any real number. Then a to the n to the m power equals a to the n times n power. Okay, so let's take a look at this one. A to the cube times b to the b squared, and then square them. And what is that going to be? So let me expand them first. So a to the cube means you will have 3a multiplied together. B squared means 2b multiplied together, and then you square them. Remember, square means you multiplied yourself again. Now we will group them. All the A, group them together since it's multiplication. By commutative property, you can regroup them. So I have how many A's? 6 A's. For B, we have totally 4 B's, which is the same when you multiply them. Basically is you distribute the two inside the parentheses and multiply them. So in here, this is equals to A times A to the 3 times 2 times B times 2, which is A to the 6th power and B to the 4th power. Okay, so look, the product rule, the power of a product rule. Let AB be the positive real number and N be any real number. Then you can just distribute the N inside. Okay, so this is happen all the time. If this is addition, doesn't mean you can distribute the M inside. In here has to be multiplication. So for example, why is that? A plus B squared is not equals to A squared plus B squared. This is wrong. Because let me expand them. So I have A plus B squared. That means you multiply A plus B times A plus B. And then we FOIL them with A squared plus AB plus AB plus B squared, which is equal to A squared plus 2AB plus B squared, which is not equal to A squared plus B squared because they still have 2AB. This only works if A times B to the mth power. So this is equal to A to the m and B to the m. You can only distribute them when they multiply. If it's addition, no. Okay. So for this one, evaluate by expanding it first. So look, we have A over B to the cubic power. So this is equal to what? A over B times A over B times A over B. If we group the same number together, what we have? We have A to the cubic power over B to the cubic power. So that means you can distribute that power into the fractions. Okay, apply the power rules for the exponent to simplify the following expressions. So in here, because inside the parenthesis, this is multiplied, that means you can apply the third exponent inside the parentheses by multiplying them. So you have 5 to the third power, and then A to the 4 times third times B 1 times 3. Okay, so when you simplify it, you have 5 to the cube equals to 25 times 5, 125. Okay, I'm almost right about that. And then A to the 12th, and then B to the cubit. So that will be your final answer. Okay, so in here, you distribute the 2 on the denominator and the numerator. So I have B 5 m to the third square over 9 n to the 4th, and then raised to the 2nd power. Now we distribute the 2 inside, we have 5 square m times 3 times 2 over 9 square and 4 times 2, which is equal to 25 m to the 6th power, and then 81 m to the 8th power. So next one in here, what are we going to do? Well, we do everything inside the parentheses first, right? So now let's distribute them. So we have x to the 3 times 2, y to the 4th, and then we distribute the third power inside the denominator. We have x to the cube, y to the 3rd. So I have x to the 6th, y to the 4th, and then x cubed, y to the 3rd. And then, since this is what? A fraction, By quotient rule, we can subtract the exponent. So we have 6 minus 3, y to the 4 minus 3. So we have x to the third, y to the 1, which is x cubed times y. Okay, so for this one, evaluate by applying the rule. Okay, so a to the third over a to the third equals what? A times a times a over to a times a times a, which is, they can cross cancel everyone. What's left is 1. So that means what? Bioacrosion rule, we know that this is equals to the exponent from the numerator, subtract the exponent to the denominator. So this is a to the 0. So that means a to the 0 is going to equals 1. So this is called zero product rule. If the base is any real number, a to the 0 power is equals 1. This is always true. Okay, so apply the zero rule to simplify that. Maybe try to pause and try to do it by yourself. Okay, so we don't care whatever inside it is, as long as a 0 power, this is equals to 1. Okay, similar to here, we simplify everything inside the parentheses first. So we have 3 times x squared, y to the 0 equals to 1. And then 5 times x0 power is 1, and y to the 4th. So in here we have x squared, 5 to the y4th, and then we merge the like terms. In this case, it's the number. So we have 15 x squared, y to the 4th. Okay, negative exponent. So let's expand in this. A to the third, a to the 5th. This is equal to what? So we have a to the third, which is 3a multiplied together. A to the 5th, we have 5a's multiplied together. And when we simplify it, we will have 1 over a times a, which is 1 over a squared. But from the previous lessons, we know that the quotient rule, by quotient rule, we have a third over a to the 5th power is equal to 3 minus 5, which is a to the negative 2. So now let's connect these two together. So that means a to the negative power is equal to 1 over a to the positive 2 power. So here is the negative exponential rule. A to the negative n equals to 1 over n. Or in this one, if there's a negative exponent in the denominator, that means what? You flip them again, right? So this is basically equals to, if you see a negative n, you will see 1 over n. You flip them again, so which is equals to 1 over n. So in here, 1 over b to the negative n, that means you flip them upside down. The denominator and the numerator, it's like they're reciprocal. You flip them, and then you will get a positive exponent. Okay, so here are the warnings. It is important to note a negative exponent does not imply the expression is negative, only the reciprocal of the base. Like I say here, doesn't mean a and b is a negative number, it only means they are reciprocal. Okay, and also we call the rules of simplifying. All exponent has to be positive. So that means if you see a negative, the first thing you think of, if you either need to flip them to get a positive exponent. Okay, so each base only occurs once. That means you need to merge the like terms. There are no parentheses. That means we need to simplify them. There are no power returned to powers. That means if we see power returned to the powers, we need to distribute them by applying the power rules. Okay, so pause the video and try to do that by yourself. Okay, welcome back. So let's see. Now we see a negative. The first thing we do is we flip everything inside the parentheses or whatever the negative number to. So to make the negative become positive, because we can have the exponent to be a negative number. So here is m to the fourth, m to the third, because we flip them upside down. I have m to the fifth to the second power. So you can distribute the two inside, or what I would do is I want to simplify everything inside parentheses first. So I have what, m to the fourth and m to the just one power. This is have what, m to the third power left. And then here I have m to the second power and m to the second. Now we distribute, because look, there are no power returned to the powers. So that means we need to distribute the second power inside the parentheses. We have m to the 3 times 2, and then m to the 2 times 2. When you distribute, you need to distribute the power both in the denominator and the numerator. So here we have m to the 6 over m to the 4th. So similar to here. So now let's take a look. M to the negative 5, we have a negative. That means we need to flip them upside down so that we can get a positive exponent. Similar to here, 3 to the negative 1, we put them on top. And z to the negative 4, we put them on top so that we can get the positive. Okay, so we have a 7. What need to move on top? 3 is going to move on top. Z to the negative 4, after they move on top, the negative sign gone. We will get a positive. Y remain in the bottom. And x to the negative 5, once they move in the bottom, is going to be a positive 5. Now merge the like terms. That's it. Okay, so this one, we have a to the negative 4. We don't want to see the negative side, so we move it on the top. So we have 2 times a to the 4th power and over 5. So we have 2/5 a to the 4th. Okay, so here are the property of the exponents, what we just learned today. And now let's do more examples. So in here, always parentheses first. You need to distribute the 2 inside of every thing, totally 14th. So you have 4 to the second power, x to the 5th times 2, y to the 2 times 2, z to the 2. And then for the second one, the same. 2 to the 4th, x to the 4 times 4, y to the negative times 4, z to the 3 times 4. Okay, so now what? We simplify them. We have 16, x to the 10th, y to the 4th, z to the 2, and then 2 to the 4th power equals to 16, x to the 16th. Okay, so y is equals to negative 8, z to the 12th. Okay, when you see negative 8, what do you think? Negative 8 means you need to put these down. We want to get a positive number. So this has become a denominator of a fraction. So this is going to be y to the 8th. Okay, so let me rewrite this nicely. We have x to the 10th, y to the 4th, z to the 2nd, 16, x to the 16th, z to the 12th, over y to the 8th. Now we merge the like terms together. 16 times 16, I don't know, equals to what? Use your calculator. It's 16 squared. And now x is equals to 10 multiplication, means you need to add the exponents. 10 16ths. Y is 4 subtract 8. Z is equal to 2 plus 12. So I have 16 squared, x to the 26 power, and y to the negative 4 power, and z to the 14 power. Again, we want to write nicely. You are not allowed to have exponent. All exponent has to be a positive number. So that means this has to be in a fraction form. So I have 16 squared, s to the 26, z to the 14th, over y to the positive 4 power. Nice, nice, right? Okay, let me do another one. Since I don't have space, I'm going to do C. Okay, so again, the first thing you will see is you try to put all the exponent inside the parentheses. So I have what? 2 to the 4th x. I should do all of this. 4 times 2 times 4. Now we get 8. And then y is 3 times 4, 12. And then again here, you have negative 2 times 4. You got negative 8. And then y is negative 6 times negative 2. You have positive 12. And then you have x minus negative 6 times 2. You have negative 12. And then 2 times 4, you have y to the 8th power. So in here, you can either flip them first, or you can just merge the like term first. Either way, that works. There's a multiple way to do it. In my earlier example, I flipped them first. I see a negative. I want to get rid of the negative sign first. But now I want to keep it. I can just reduce the negative sign at the end of the process. Now I'm going to show you how to do that. So, okay, I'm going to merge all the like term together. So I have 2 to the 4th power, which is 16. And then x, we merge the like term together. X to the 8th. This is add because of multiplication. You add a negative 8. And then y to the 12th. Add 12. Over x to the negative 12, y to the 8th. So I have 16th, x to the 0, and y to the 24th, and then x to the negative 12, and y to the 8th. Now, x to the 0s equals to 1. We multiply 1. And y, how do we do y? Quotient rule. By the quotient rules, we have 24 minus 8. And then x to the negative 12. We're still keeping the negative. We have y to the 14th, and then x to the negative 12th. Okay, now you see the negative. How can I get rid of the negative? We flip them, right? We flip them on the top. So the negative sign will gone. So we have x to the 12th power and y to the 14th power. Okay, that's it for today. Let me know if you have any questions about the quotient rules. See you next time.